Hey there, my name is Anastasia and this is a long overdue follow-up video on SQL one-on-one that I did 1.5 years ago, and we will continue looking through functions and different useful things that you can learn in SQL, specifically BigQuery notation of SQL, that are relevant for your data analyst or data scientist job. Without too much introduction, let's get into it. As I mentioned in a previous video, if you have a Gmail account, you can have a developer access to GCP, Google Cloud Platform. It's pretty useful to test your queries and just, prepare for this role as a data analyst, especially if the company, as many do right now, has a Google Cloud Platform, stores their data in BigQuery, and computes things through BigQuery or connects BigQuery to other tools like Looker, dashboards, different kind of stuff. So do recommend you creating this account and getting into BigQuery. I found it the easiest, the cheapest, and the most straightforward way to both do analysis on your own data, on data that you receive from different data science challenges, and also on just Google accessible data, for example, like data on COVID and other statistics that they calculate. Be, of course, wary of how much you load in there, how much you store, and how heavy your queries are. So for this example, I created pretty basic queries and very small tables, just so that through running them 10, 20, 30, 50 times, I don't get charged for using the API. And I think for a month you have around $200 of free usage. And after that, it starts to cost you something and you'll have to pay. So just check out the billing part here in the project that you've created to see whether you owe anything. And yeah, for me, current month, I don't owe anything to Google, which is great. So let's get into it. Again, on the starting page of Google Cloud, you select the project. If you don't have the project, you create it, and we get into BigQuery. Here I have this data set, the project with different data sets, and we're gonna work with SQL one-on-one. I even have already some queries that I've started with. A nice new feature. Well, actually, I really don't like the tabs things in BigQuery. I think they're horrendous and the user experience is just obscene, but we will work with what we have. So let's start with user data and with trying to understand who our users are, how can we group them, how can we analyze them. For that, we will look into user data table. We have here a few different columns. User ID, of course, it's an integer, so numeric. User age, of course, as well, integer, numeric. When the user ID, presume, was created, the revenue for this user, it's numeric and decimal, so 10 digits and 2 digits after the comma, so because you can't have less than a cent. And if the user is a subscriber of our imaginary product, and this one is Boolean, so true or false. Let's see how this table looks like. Let's remove this part. And we have 4 users with different user IDs, different user age, different time when they were created, and we only have 1 subscriber. Let's see. Yeah, we only have 1 subscriber and only 1 paying customer. So the same person is the paying customer. Other users have a revenue of null, not 0 though. Note that. So first of all, let's assume that we want to group our user base based on their age into 3 different groups, minors, adults, and seniors. For example, maybe we want to offer them different products, or we want to know whether they have different spending patterns. Of course, it doesn't really mean much when we only have 4 users, but if we have 4 million, things are very different. So let's get into it and open the editor for queries. And of course, you can do it even faster if you open query create query, there you already get the table preset. That's pretty nice. Since we want to group the users that we have, here we will use the case when notation, case when function, to check the user age and assign a certain string according to the 3 different user groups that we've defined. So for example, when user age is less than 18, then we do minor. When user age bigger or equal to 18, since we need to include the 18, and user age is less than 65, then it's an adult. Else, all other options we assign senior. And we end this case when statement as age group, for example. So we name this new column and we just can count all of the users. Since we've saw that in this table our user IDs are unique, we can do that. Otherwise, if we don't know if they're unique, we need to count distinct user ID as total customers from this table. And here we have an error complaining, and that's because we need to do a group by, since we do a grouping by user ID and by age group. So just add that grouping. And here we have this lovely mark which says that we will process 32 bytes when we run this query, which means that it's pretty cheap. So here we see that we have 3 groups, 3 age groups, and in each group, in senior and minor, we have 1 customer, and in adult we have 2 customers. Yay! Do already have some data analytics. This won't work if, for example, we have a null value in the age row, in the age column, because that user will be assigned to senior, so that won't be correct. So we will, for example, have to do an IFNULL check. But in this example, we don't have the null value in age group. We do have it in the total revenue column. So let's use also the total revenue column. Maybe we want to see how much we earn for each of these groups. So we can do the sum of total revenue as also total revenue. And we run. I run with command enter, by the way, just so that you know. And here we have like the very unpleasant null for the revenue for senior and minor groups, where we don't have paying customers, which is not very fun. So we can substitute that null with 0, and we can do that if we add IFNULL function and add a 0. So if the total revenue is null, we assign 0. Otherwise, we use the total revenue value. And here we go. That makes a little bit more sense. So it's $0 and not null dollars, or whatever the currency is for that number. So here we already learned how to group and how to check for the values. Do definitely recommend to always preview the tables and extract a few values and see what kind of different and distinct possible values and value types are there in every column. Because, for example, if you extract, just preview the first 10 rows and you don't see that there are null values, and then you don't do the null check, can affect your calculation. Also, a neat thing is that you can just format your query after you're done writing it. I usually write it obscenely, horribly, not nicely, without the proper capital letters and without the proper line separation. So that's this makes it much easier to read, but it is much harder to write it like this. At least for me, I prefer to write it all, just how I think about it without focusing too much on the formatting. But of course, you can't do that, and you can't really store those queries, even just for your own self. It's much easier to read it like this. So we've calculated the total revenue. We know how many users we have in different age groups. We know how many total customers we have in different age groups, and we know how much each age group earned us. But for example, we also need to know whether we processed and delivered all the orders that we have placed, that our users have placed. So here we'll start joining on other tables, and let's first check the table that we will work with next. So it will be the orders data, and this table has order ID, user ID, which will be the key that we will connect those two tables through. We know when the order was created, we know the price for this order. Maybe this could be written or described in a different way, better naming for this column, but it is what it is. Let's call it the price. And we know the status of the order, which is a string. And we can also ask to preview. So here we know that we also have only 4 orders in total, and it's the same user ID that created all the orders. They were created, 2 of them were on the 5th of December, and 1 on 4th and 1 on 7th. They all had different prices and they had different statuses. So the one that's on the 5th of December, for some reason, is still in progress, whereas the one on another one on the 5th was already delivered, and the one on the 7th is created but not in progress. So maybe a little bit of a problem here. So let's continue writing up our query. We will use the age group part that we've created there just to group by age group if we want to, for some reason. Maybe we do. Additionally to the count of the total customers, we will also calculate the order price. So we'll sum the price for all the orders, and we will calculate the order status. We'll get the order status from the orders table, and we'll see how many orders are there, how much all of them cost for every order status. So for that, first, of course, we get the user info, because we need to be able to group users by their age. This can be a different metric that you can group by. It doesn't have to be age. I'm not sure this whole thing right now makes sense, but of course, you can derive from that and apply it to the exercise that you have to do or the query that you need to write in the company you work for. So from user data, we get the user info, and from orders data, we get the order info, and we will join this on the user ID. And we're doing an inner join here, so you can write both join and inner join to note that the tables are joined only, and you get the output only if the user ID is present in both tables. So we won't get any output for the users that didn't make any orders. And now we group by and age group as we did already, and order status from orders. Let's make it nicer. And now we run the query and we see that it takes a bit of time. Wow. So we have 3 total customers, which is not exactly true, but they all have different statuses for their orders. We can see that we have delivered for $335 or whatever currency. We have in progress orders, 1 order for 76, and we have a 1 order that's created for $154.99. This gives us some information, for example, that we need to take care of the created and non-delivered orders. We can also filter here by the value that we've already calculating. So that's not existent, and that's the having function. And for example, we only want to know for the orders that are above, I don't know, $100. And in that case, we only get 2 rows. Even though this kind of grouping and summing and calculation look pretty basic, that's something that you will have to do a lot. And often when you get a question from a product manager who wants you to group for this specific group of users and type of users, how many different projects, how many products they purchased, or I don't know, how many minutes they listened to something, how many taps they did in the app. Often this data is not available in dashboards or in any other tools that are accessible and easy to use for a product manager or someone who's not very familiar with SQL and data analysis. And you will have to answer those questions. So believe me, these kind of basic things will come in handy, and especially important for these basic things is being able to know which kind of limitations apply to this query, where there are null values, where there are broken values, any kind of filtering that you need to do, being clear on, for example, that when we see the total customers 1 and 1 in each row for order status, that we don't think that we have 2 different customers. This can still be 1 customer. And more often than not, those errors do happen and those mistakes appear. So thinking about different limitations that DataSite is giving to you is really important when you're writing these seemingly super basic, easy queries. Thank you for watching, and see you for another video where we dive deeper into SQL for data analytics and data scientists. And the next one, we will focus on date manipulation, time manipulation, and do some regex and string manipulations. Hope that was useful. Thank you and have a nice day.